Hello everybody, welcome to another mystery box function challenge. In this purple box there is some mystery math. Whatever number you put in the top, it's going to transform it into something else when it comes out the bottom. Those ins and outs will be recorded here in this chart so you can look back at them, and then they'll be graphed as ordered pairs so you can see the shape that this mystery math makes. Your job is to determine what's inside this purple box. You can click on the link in the description, go to this page and put in as many numbers as you want. Pause the video, do that, come up with a good guess, and then come on back and see if I get the same thing. All right, well, let's see what this mystery is all about. I'll put in a 0, and I get a 1, so it looks like we're adding 1 maybe. Let's put in a 1, so this might be a 2 if we're just adding 1. No, definitely not a 2. So that's a 4. Let's put in, so this might be just a steep line with a slope of, let's see, up 3 over 1. So that would be a slope of 3. So maybe it's the line 3x plus 1. Let's put in a 2. 3x plus 1 would be 7 if that was the case. Oh, but that's 9. So I don't think that's a line because it went up 3 and over 1, and then it went up 5 and over 1. So maybe this is some kind of quadratic. So let's test the points on the other side. So let's test like a -1. And if this is symmetrical, no, it's not symmetrical. Okay. So some other type of curve. Let's try -2. Oh, aha. Now I'm starting to think it is a quadratic. For a moment there, I thought it wasn't. It looks like the quadratic has been shifted over to the left. So maybe if I put in a -3, that point will be symmetrical, well, across not the y-axis, but that line x equals -1. So let's put in a -3, and I'm going to predict it comes out as a 4. And if I put in a -4, it should be a 9 if it keeps this symmetry. Yeah, so we're getting that curve of a parabola. So I think we're pretty sure that this is a quadratic. So it's got x squared in it somewhere, but instead of being shifted up or down, if it was shifted up or down, it'd be pretty easy because you just add onto the end or subtract to move it down. But this time it's moved 1 to the left. So how does that work with a quadratic? So if you take the squared part and put it in parentheses and put the x in here, and then to shift it left, you actually add 1. This may seem counterintuitive, right? Because we're going, normally it would start here. We're going in the negative direction. So why do we add 1? Well, think about this. Let's test a couple points. So let's test the point 0. If I put in 0 here, I get 1. And 1 squared is 1. So the point 0, 1 should be on here. And it is. That's that point right there. If I put in the point -1, and that's a good point to put in because I would want to make what's inside this 0 to find where the vertex is. So if I put in -1 here, -1 plus 1 is going to be 0. Then we square that, we get 0. So the point -1, 0 should be on here. And it is, and that's the vertex. So if you see a parabola that's shifted left or right, if you want to go in the negative direction, you add whatever number of spaces. We went 1 space to the left, so we added 1 here. If you were going to the right, you'd subtract it, and it would work on a similar principle, except in the reverse. So this is a tricky one, but I think this is it, and we've already tested a couple of points. Let's put in one more point. Let's put in a -4. So if we put in -4 for x, and then +1, and then square it. Well, -4 plus 1 is -3, and -3 squared is a +9. And look, we put in a -4, we get out a +9. So I've tested 3 points with this now. I'm pretty sure that this is correct. F of x equals, in parentheses, x plus 1 squared. So let's take a look. Yeah, and that's exactly what we've got, x plus 1 squared. And let's look at the graph. Yeah, beautiful. curving parabola, just shift it over 1 to the left. Well, how did that go? If you got an answer where you had actually FOILed this out, that answer is correct too. So if you got x squared plus 2x plus 1, that would be correct. Did you get this answer, or did this one stump you? Let me know. Thanks, everybody.